Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 168 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. My name is Tim Robertson, and I'm the host of the Observer's Notebook and also the coordinator of the training program within the ALPO. Thanks for downloading and listening. The ALPO collects and analyzes observations of various solar system bodies and associated phenomena, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners, to keep it going. If you enjoy what you hear on the Observer's Notebook, you can donate to it via Patreon for as little as $1 a month. If you feel even more generous, for $5 you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can help us out by going to www.patreon.com/observersnotebook. And if you'd like to join the Association of Lunar and Planetary Observers, membership begins at only $22 a year. For more information, find out more at www.alpo-astronomy.org. And you can also find us on Facebook. Just search for ALPO Astronomy. And this podcast has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear in the podcast, please subscribe. That way you'll never miss another episode. And now we're continuing on with our observatory series with McDonald Observatory. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. We have with us today, we are continuing the series of historic observatories. And this observatory, I've had a number of my listeners ask if we're going to do it. And this is McDonald Observatory. And with us today, we have Katie Kizziar and Steven Janowiecki of McDonald Observatory. Welcome.
Thanks. Hi.
And the reason I think I've had a number of people ask is because your connection to the Texas Star Party. They're like, oh, you got to have somebody from McDonald. I said, yes, they're on my list. We've got them going, and now we're finally doing it. Well, before we get into talking about the observatory, why don't we just touch on each of you? Katie, give a little bit of background about yourself.
Sure. I'm the Assistant Director for Education and Outreach at McDonald Observatory. I don't come from an astronomy background, but my career has been focused on STEM education and outreach. So this is a wonderful chapter to get to undertake. I focus on the work that happens through the Visitor Center on site at the observatory, as well as publications like Stardate Radio and Magazine and other communication efforts to help spread the word of what we're doing. So happy to be talking with you.
Great, thank you. And Steven?
Sure. So I'm here at the McDonald Observatory as well. I work mainly at the Hobby-Eberly telescope, which is the biggest telescope we have here on site. So I'm one of the astronomers who uses that telescope at night. I'm the science operations manager over there. So when the sun goes down at the HET, the Hobby-Eberly telescope, I'm the one responsible for the folks who run the telescope at night. So that's me. I do have an astronomy background. I started looking at the sky as a little kid with my mom, and then went on to study astronomy, and couldn't be any happier than living and working here at one of the biggest telescopes in the world. So
that's great. Now, was there an event or something that triggered your interest in astronomy, or?
Oh, we did a lot of camping as kids and got out into the country and looked at the sky. We'd look out for meteor showers or comets that went by, a lot of naked eye observing or binoculars. Later got a telescope, but started out just appreciating the nice dark night skies.
You have a dark sky where you're at now.
We sure do. Yes. It doesn't get much better than this.
Yeah. And we'll talk a little bit about that later. But so let's talk about the history of McDonald Observatory. Where, how did it start? Things like that.
So I think a good place to start is with Mr. McDonald and how we received that name. So William J. McDonald was a Texas banker He was not a scientist. He made quite a good deal of money in the 1800s, and when he passed away in 1926, he left the majority of his estate to the University of Texas to create an observatory. So this was the designation of his will. Even though, like I said, he wasn't a scientist, he had no affiliation with the university at that time. He just felt it was a really important thing for the state of Texas to have. I think he had experience perhaps getting to see Harvard's observatory through some travels that he had done later in life. So this was a gift to the state of Texas. Like I said, he passed away in 1926. So in the early 30s, the university started to look for a location on which they could place an observatory, and settled in these beautiful mountains, the Davis Mountains of far West Texas. So we're located 450 miles west of the University of Texas campus, which is great because it made sure that we have had preserved dark skies this whole time. But it is also quite a bit of a distance for a research facility, for a research lab. And so that is how we came to be, and we're very grateful for that. A piece of the story as well is the generosity of Texas landowners. The university actually wrote to one of the ranchers out here, Mrs. Violet Locke McIver, and we are still neighbors to the McIver Ranch to this day, and said, you're probably not using that little mountain over there for anything. Wouldn't you donate it to Texas so that we can build this beautiful observatory? And she said yes. And so Mount Locke is where the original observatory 82-inch telescope was built, and where we've also have our 107 or 2.7 meter telescope. And it's named in honor of their family. So Mount Locke, thanks to that gift. And then similar with Mount Fulks, where the Hobby-Eberly telescope is built, was another gift from our other neighboring rancher.
A lot of friendly Texans out there, huh? Very nice. Now, how is the observatory funded? Is it through the university or through grants?
So it's a mixture. It is the university. We do receive some funding. We also receive some state funding as being a state research institution. So not just University of Texas students and researchers can use these facilities. We have researchers from all over the world can use our facilities, but we definitely are supporting a lot of Texas students from multiple institutions. So the state of Texas supports us, and then quite a bit of grant funding to help get researchers here. And then the Hobby-Eberly telescope, I'll let Steven mention it because larger telescopes involve more hands to help support the work. So it's a bit of a consortium project.
Yeah, exactly. So even though Texas is big, it's not big enough to support a telescope as big as the HET, the Hobby-Eberly telescope. So we have an international collaboration that runs the HET. The University of Texas is by far the largest partner, but they couldn't do it alone. No telescope that big is operated by just one university. So we partner with Penn State University, and a couple of other universities in Germany now are part of our team that makes it work, and we share the operating costs of the telescope, and we also share the access to the telescope to anyone who's part of that collaboration. So it's not quite as wide as the whole McDonald collaboration, which is open to a lot more people, but the HET is an international consortium that runs that telescope.
Okay, and what is a Hobby-Eberly telescope? What is it for?
Oh, sure. So it's gone through a couple of different sort of phases of its life. It was designed in the 90s, sort of as the next big telescope for McDonald Observatory. We've had kind of every 30 years, we've had another giant step forward in telescopes, and this was the next step after the 107-inch. It was designed to be optimized for spectroscopy. So this is when we take the light from a distant object and break it up with a prism or something like that into a rainbow of colors and measure how much of each color comes to us from that object. The observatory site here is really a long-standing spectroscopy powerhouse. We've done a lot of powerful spectroscopy with different instruments and different telescopes here, and the HET sort of fits right into that. It was designed in a really unique way to have a slightly limited range of motion that the telescope can actually move through, but at a significant cost savings for the initial observatory building costs. So you probably are familiar with how telescopes work, and often, especially big telescopes, are on what we call an altitude azimuth mount. So they can tip up and down, and then they can rotate around in a full circle. Well, if you want a telescope to have that much range of motion, it needs to have a lot of space to move through. So your dome has to be really big, and you need a very expensive, but a very complicated and heavy mount that can precisely move the telescope over all those potential positions. So what we did as a compromise is our telescope is mounted at a fixed elevation. The HET observes 55 degrees above the horizon and only 55 degrees above the horizon. So we can rotate it 360 degrees, but we have to wait until objects get to our observing altitude to observe them. But that lets us build in a very small footprint and with a very cost-effective design, so we can put all our money into the spectrographs, into everything else that costs money. And we built a 10-meter class telescope, which at the same time the Kecks were being built, which are 10 meters. They were built for about 100 million, and ours was built for about $20 million
oh my goodness.
at that time. So it was a massive cost savings. Since then, we've done a $40 million upgrade. So it's much improved, much expanded capabilities than we had originally. And it was really great originally, but it's also important to mention that it's a segmented mirror telescope. So you can't build one mirror that's 10 meters across and have it work very well. So it has 91 hexagonal segments that fit together in like a beehive honeycomb shape. And it was one of the first telescopes to have a segmented mirror like that. So we're proud of that. And it's still doing amazing spectroscopy. We can talk if you want about the current work.
Tell me what's going on at the observatory right now.
Yeah, so that $40 million upgrade I mentioned, that was a really big effort to study what astronomers call, but don't understand, what we call dark energy. So we know that when you look at distant galaxies, they're all moving away from us. That's because the universe is expanding. And we've actually measured, as you look at more distant galaxies, the speed of that expansion seems to be different at different times. The universe is expanding especially fast right now, and we see that expansion is accelerating. It's a hard measurement to make, but it's a relatively simple one to understand, that we can measure a change, and that change is changing, and we call that acceleration. So what we don't know is why the universe is accelerating. We aren't probably going to solve that question here, but what we're doing is we're looking with the Hubble telescope farther back into time than anyone has looked before to measure the expansion rate at an earlier time in the universe. So we know it's accelerating today, which means it probably wasn't accelerating at some point in the past. So we're trying to look back about, I think it's 8 billion years. I forget it in years.
Oh my goodness.
We're trying to look back to an early stage of the universe to see how strong was the expansion rate way back then. And that can tell us when did this dark energy thing start, and how much of a role has it played back in history. But it's a major project. We had to build a whole new instrument for it.
Wow.
We built a new spectrograph that's the most powerful, widest field of view spectrograph in the world. It was a really clever name until a few years ago. It's called the virus spectrograph.
Oh, no.
I know. Right? But it's many copies. It's a replicable spectrograph. So we built 78 copies of the same spectrograph, like a virus reproduces. And so with that, we can observe tens of thousands of spectra on the sky at the same time and study millions of galaxies to measure this acceleration signature that we're looking for. So that's the Hubble Telescope Dark Energy Experiment. That's the big survey that we're probably 2/3 of the way finished with data collection with the actual observations, and then there's a lot of analysis and processing to be done after that. So it's going very well.
Okay, and now go on.
I was going to say, and in fact, there's a really fun community science project that is affiliated with the HETDEX, as we call the Hubble Telescope Dark Energy Experiment. So the Dark Energy Explorers is on Zooniverse, and some of our PhD students and faculty researchers who are working on HETDEX worked to create a program where basically you can help us with identifying and classifying these galaxies for the data analysis. So the HET can collect so much data, and in order to identify all the galaxies to add to the survey, that's a lot of information to process. And so I think I was just updating a poster, something like 3.2 million classifications have been completed by 11,000 volunteers.
Oh my goodness.
And we jokingly, although some people cringe, call it the Tinder of galaxies, because you swipe right for one type of classification and you swipe left for another. So it's very simple, just visual identification, but a great way that we're trying to engage the public in this work. And also we really need the help to get through all of that information.
So this is like a citizen science project?
Yes. Okay. Yeah. It's called the Dark Energy Explorers. And then there's a website at hetdex.org that has more information all about the research project and how people can get involved in that.
Great. I'll find that link and I'll put it in the show notes so everybody can click on that and go over there and check it out.
That would be great.
Now, what about the GMT? Are you guys involved with that? How's that process going?
Yeah, every new telescope kind of builds on the foundation of what we've learned so far. So University of Texas is a big partner in the GMT. It's also a major international collaboration, and that's kind of our next big telescope on the horizon. It's so big we couldn't even put it in Texas. It has to be down in Chile instead. Yeah. But we have a number of astronomers working on projects that will be observed with it. But I think we also, I don't know if Katie wants to say, we have an instrument that we're helping to develop on that telescope.
Correct. We're working on a near-infrared spectrograph that will be used on the GMT. And so I like this because it feels like a very Texas maverick story to me. Our vice president of research, who is an astronomer, Dan Jaffe, and then some of our researchers and engineers, Hanshin Lee, Cynthia Froning, I think some other folks are involved in this too. Basically trying to create the spectrograph unit for this next class of 30-meter, going to be the world's largest telescope. Well, there aren't the manufacturing techniques to produce the type of instrument that is so cutting edge. And so we are basically within the University of Texas developing this new instrument along with the manufacturing technique, which is going to use some of the similar techniques that semiconductors do, so that you can get really, really fine etching on the diffraction gratings. So one of the projects that we're working on that's really exciting is that we're actually going to put some of our scientific instrumentation directly on the instrument, as well as being a large partner, which means that we'll get quite a bit of the observing time once we're on sky. So very exciting project to be a part of for McDonald, for sure.
Fantastic. Now, there are other domes up there that are related to McDonald Observatory. What can you talk a little bit about those?
Sure. Yeah, I kind of jumped ahead a little bit in our history story. So once we received Mount Locke, I mentioned, our first telescope, the 2.1 meter, the 82-inch telescope, was completed and dedicated in 1939. March 5th, we'll be celebrating our birthday coming up in the spring. And that was a pretty cool event historically. The AAS was having a meeting in Alpine, which is about 45 miles or so, but the train stops there, and that's actually how the telescope parts were brought here originally to the site. So they had quite a crowd of notable physicists and astronomers who were on site, and we have some great photos that you can see from that event. And then thinking again, we're still fairly remotely located, even in modern day, but considering how they had that many people on the top of the mountain and, fed them a real deal chuck wagon lunch, where they did barbecue in a trench, and everybody was there in their, finery. So that telescope still in operation today for doing scientific research. Our visitor center can occasionally apply for time on the 2.1 meters so that we can host special viewing nights for the public, so that they can come up, put an eyepiece on, look at objects in this historic instrument. It's really a beautiful piece. And then, so the University of Texas didn't have an astronomy department when the first telescope was completed. And so we partnered with the University of Chicago, and Otto Struve, who was directing the Yerkes Observatory, co-directed. And so for the first 30 years, University of Chicago was actually leading much of the scientific work that was taking place here. By the early 60s, UT had developed an astronomy program. And so Harlan Smith was the first director for the observatory. He was also the chair of the astronomy department at the time in the early 60s. And he worked with NASA in the late 60s to build the 2.7 meter, which was, we're starting the space race. We're sending people up there. We got to have bigger telescopes down here to do follow-up science. And so that's where that instrument came to be. So as Stephen was mentioning earlier, kind of our every 30 years. And when UT, kind of came to its own and took on full leadership of the observatory, we added in quite a bit of housing. So there are residents who, as Stephen and I mentioned, we both live here on site to help support observatory work. Also added in a lodge so that our visiting observers have a place to stay when they come out on site and get a home-cooked meal. We have our own fire department. We're a little city out here as an observatory too. So the three main research telescopes are the 2.1 are the Otto Struve telescope, the 2.7 are the Harlan J. Smith, and then our 10-meter class, the Hobby Everly telescope. And then we have a number of other telescopes. There's a 30-inch that is used quite a bit remotely operated. We have an older 36-inch that is used quite a bit for teaching, also for our public special viewing nights. And other individual research. So though Stephen is really focused on running the science for the Hobby Everly telescope and the folks who are researching there, as he mentioned, he is an astronomer and occasionally will use these telescopes for his work as well.
Okay, great. Now you talked about outreach. So let's talk about the types of outreach that you do at McDonald.
Sure. So the visitor center is open year-round. 5 days a week, Tuesday through Saturday. The site is open for self-guided tours. There is a visitor center with an exhibit hall, so with more information about the observatory, the work that we're doing, gift shop, theater where solar viewing programs are hosted. So nice weather, we can do live views of the sun through filtered telescope. There's some guided tours that we provide also, where you get to go onto the dome floor of the 2.7 and see the telescopes up close. We really pride ourselves on being kind of one of the most open to the public research facilities that can be. Even the Hobby Everly has a beautiful gallery attached to it with a window that opens up onto the dome floor so that during a visit, you can see the largest telescope in North America just on your own. Walk into a building and look at it. Wow. And then 3 nights a week, our staff also open the visitor center up for Star Party programs. So we have an open air amphitheater. There's a guided constellation tour, and then there is a number of telescopes there on site that are just for outreach purposes. So staff will have a few targets available for visitors to look at. It's about a 2-hour program in the evening. And then I mentioned we also do offer those special viewing opportunities on the larger telescopes occasionally when we can get time on the research calendar.
Very good. Now, what are some of the future plans for the observatory? You talk about every 30 years, something big happening. What do you see on the horizon for McDonald?
Do you want to talk a little bit about HRS?
Yeah, I think so GMT is our biggest, we're a big part of that, and that's sort of the next telescope plan. But all of these telescopes at McDonald have stayed current basically because we're always building new instruments to attach to them. The way the mirror reflected light in the 1930s is still the way the mirror reflects light today. So it works just as well, but the way that we capture and analyze and look at that light has changed almost completely. I mean, we still break it up into its colors, but the way we measure it, it would have been by eye or on photographic plates back in the early days of the observatory. And I don't know of anyone who does that anymore because we have amazing digital detectors. Right. So just like the new technology going into the GMT instruments, we're always building and upgrading new instruments on these telescopes here. And we see every time we build a new instrument, we get a really big spike in demand for that telescope again. So it's like it's a brand new telescope when you have a new instrument on it. So the 2.7 meter has a new instrument that's coming too, which is called Virus 2, because we just like that name so much that we can't stop. But it will be a powerful, smaller version than what we have at the HET, but a very powerful version for the 2.7 meter to do really wide field spectroscopy over a big area. And then at the HET, we're developing a new high-resolution spectrograph right now, which will look at just one object at a time, but it will split the light up at a sort of an incredible resolution that is only possible in the largest telescopes. The more you spread the light out, the higher the spectral resolution, the fainter it gets. So if you want to look at anything other than the brightest stars with a high-resolution spectrograph, you need a really big telescope just to collect enough light. to be able to spread it out. So that's expected in the next couple of years on the HET, and we expect a big spike in demand as that becomes available. And then after that, I mean, we'll just keep building new instruments for these amazing facilities that. I think all the telescopes will benefit from that. We have new instruments all the time. There's like always someone developing something or proposing something, because we have such an amazing platform here that can support whatever ideas, whatever the latest and most important projects are. We can probably hook those instruments onto our telescopes somehow.
Great. Fantastic. Now, Katie, is there anything else you'd like to share with our audience that we haven't touched on yet?
Yeah, I was just thinking about what's coming up sort of for education and outreach in the near and longer term. So part of the programs that I failed to mention directly relate to what we do with classrooms. So this summer, we invite teachers out to the site to stay at our lodge and do some work observing on the telescope or working with observers who are on the telescope, as well as learning some hands-on activities that can be used in the classroom to help teach certain science concepts. So it's a program that we've run for over 10 years at the summer, over 10 summers at the observatory. Teachers are really excited about being involved. The education staff love it, but our faculty researchers also really love the opportunity to engage and see how their work translates in that type of way. So we're getting excited about those programs this summer, and there are applications available for those for teachers to apply. We also host, classroom visits out here, but as I've mentioned a couple of times, we are fairly remote. So a lot of the work that we do with classrooms is virtually, and we can serve 10,000 students a year. We've done previously through virtual classroom visits. So those are definitely things that people could take advantage of all over the nation. Any of your listeners could check out our mcdonaldobservatory.org website and look at some of the educational opportunities that we have coming up here. And then we're also working on updating our exhibits in the exhibit hall. It seems like every 20 years or so, the sort of outreach and visitor center gets a little bit of a refresh, and our current facility has been open for about 20 years. We're really lucky that education and outreach was baked into the mission of the observatory. It was part of the will that not just that we create an observatory for the study of astronomy, but for the promotion of the study of astronomy. And we've really held true to that for the year. So we focus and invest in this type of work. So right now we have a lot of new science to talk about in our exhibits. So a lot of our staff are working on updating the content around that. And then another thing I think you mentioned too at the kind of the top of the program, our dark skies will be coming up on the 1-year anniversary of the designation of the the Greater Big Bend International Dark Sky Reserve, which is the largest dark sky reserve in the world at this point, and is really, I think, a big note of the work that has been going on for decades at the observatory to work with neighbors and educate the public about the importance of preserving our night sky, not just selfishly for our research, but because it is such a beautiful experience and why people want to come spend time in this part of the world. So we're really excited and proud about that, and are looking at how we're going to continue, to try to educate the public on preserving night skies in years to come. So it's another neat thing on our horizon.
Yeah, having dark skies just doesn't happen. There's a lot of pieces to the pie, a lot of politics, a lot of just talking to your neighbors and things like, your people with your horse ranches next to you and things like that. And it's difficult. I mean, I live in Southern California, so I could walk outside and see a second magnitude star and be excited. So that you guys should be very proud of that designation as well. That's pretty impressive. I have not been there yet, and I plan on eventually coming out to the Texas Star Party and checking out the whole facility there, though. Steven, what do you got? Anything you'd like to share?
No, I think that what Katie said is probably it. We're always building new things. I guess for me, the exciting things that I look forward to are sort of meeting new people as they come out here, which is maybe not exactly what you're asking, but we get observers from all over the world. So I've met lots of astronomers who are working on similar things to me or very different things. We get amazing visitors who sometimes ask really good questions. I was on a tour last week, and somebody asked why do you use so many different mirrors in your telescope? Why not just use one mirror and a camera? And I had to think for a second, Well, it's inconvenient, right? We don't want to mount a camera on the end of a really long stick, but like it stumped me for a second. Like so, those
Makes
kinds
you
of
think.
new experiences like that are always really welcome. And yeah, we're on the cutting edge of discovery out here, so we sort of
Right.
never know what the next thing will be, but it's an exciting place to be. Yeah.
Well, both of your passion and excitement for the observatory is very obvious to me, and I wish you a lot of luck. And I want to thank you for coming on the podcast today.
Thanks for having me.
Thank you.
All right. Well, that'll do it for this episode of the Observer's Notebook podcast. I again want to thank Katie and Steve from McDonald Observatory for coming on the podcast today and giving us a good insight to the observatory. We upload new episodes of the Observer's Notebook on the 1st and 15th of every month. Subscribe to us on iTunes. If you do, please rate and review us. I really appreciate it. And you can also listen to us on Apple Radio, iHeartRadio, SoundCloud, Spreaker, Google Play, Stitcher, Amazon Echo, Spotify, and also on the ALPO YouTube channel. You can help support the podcast by donating to it via Patreon. You can give up to $35 a month, where you will receive 1 year's membership to the ALPO and producer credits on the podcast. And with that, I want to thank the producer of this podcast, Steve Siedentop and Michael Moyer, for their generous support. The link for the Patreon as well as the link for the ALPO is in the show notes. If you'd like to get a hold of me, my email address is cometman@cometman.net or on Twitter at observersnbpod. And until next time, I hope that you always have clear and steady skies. Thanks for listening.